Good morning, everyone. Thank you for joining us today. After our deep dive into the automated world of robotics, we're shifting gears to tackle what is, without a doubt, one of the most critical topics in technology right now: AI trust, risk, and security management, or, as you'll hear me say a lot, TRiSM. Look, AI isn't some far-off sci-fi concept anymore. It's here, and it's actively reshaping our world. But with all that incredible power, well, it comes with a need for a new rulebook. So, let's get into it.
And really, this is the fundamental question we all have to confront, isn't it? AI is the silent partner in our search engines, it's the invisible hand curating our social media feeds, and it's becoming a major voice in some really high-stakes decisions. Think medical diagnoses, credit applications, you name it. And as this tech weaves itself deeper and deeper into the fabric of our society, its ability to learn, to adapt, and to operate on its own introduces a whole new class of complex systemic risks. The old ways of managing technology, the old rules, they just weren't built for this.
So here's how we're going to break it all down today. First, we'll start with the core problem of powerful AI. What makes it so different? Then, we'll introduce TRiSM as the framework designed to solve that problem. From there, we'll explore the pretty unique threat landscape that comes with AI. And finally, we'll take a look at how this new rulebook was forged in the first place.
Okay, first up, why do the old rules for tech governance just fall so flat when we start talking about AI? This really requires a fundamental shift in how we think about technology.
You know, for decades, the main benchmark for success in AI was pretty simple: performance. Does the model correctly identify the cat in the photo? Does the algorithm generate text that makes sense? The whole focus was on this very narrow, very technical definition of "it works." But as we're about to see, that standard is now, well, it's dangerously obsolete. The new question isn't just if AI works, but whether it works responsibly.
So what's really driving this big shift? It boils down to four key factors. First off, the sheer scale of impact. We're not talking about small-scale apps anymore. An error in an AI credit scoring model can deny thousands of people a home. A tiny flaw in a self-driving car's perception system, that can have fatal consequences. At this scale, that old move fast and break things mantra of software development becomes a massive liability. Second, we have what's known as the black box problem, and we'll dig into that in just a second. Third, and this is a big one, is the automation of bias. See, an AI learns from the data we feed it, and if that data reflects our own historical injustices, the AI becomes a super efficient tool for amplifying that injustice on a scale we've never seen before. And finally, all of these issues have led to a huge public trust deficit, and you're seeing a wave of new regulations, like the EU's AI Act, popping up. Responsible governance isn't a nice-to-have anymore, it's a legal and ethical requirement.
Now, this slide gets right to the heart of that black box problem I just mentioned. On the left, you have traditional software. As developers, we love this stuff. It's deterministic. It follows explicit, human-written rules. If this, then that. If there's a bug, you can literally trace it back to a specific line of code. But modern deep learning AI on the right, that's a whole different animal. It's not explicitly programmed. It learns its own rules by finding patterns in these massive datasets. This makes its internal logic, well, opaque. We often can't really know why it made a specific decision. And this lack of explainability is a gigantic challenge for accountability. I mean, if we don't know how a decision was made, how can we possibly trust it? So with these brand new challenges of scale, opacity, and bias, we obviously need a new approach. And that brings us right into Section 2 and the solution we're here to talk about, the TRiSM framework.
So what exactly is TRiSM? The most important thing to get is that it's not a single product you can buy or a piece of software you can install. It's a holistic strategy. It's a governance framework, one that was really popularized by the research firm Gartner. Think of it as a systematic approach that covers the entire AI lifecycle, from the moment you start collecting data, all the way through training, deployment, and then ongoing monitoring to make sure that the models we're building are reliable, fair, and secure.
TRiSM is really built on these three interconnected pillars. And there's a fantastic analogy for this. Think of trust as the North Star. It's the ultimate goal, the destination we're always aiming for. Risk management is the proactive navigation process. It's the map and compass we use to steer towards that star and avoid the hazards. And security management? Well, that's the set of defensive practices we need to protect the ship from pirates along the way. It's a complete 360-degree view.
So let's dig a little deeper into that first pillar, trust. In the world of TRiSM, trust isn't some vague, fuzzy feeling. It's a measurable outcome built on these four key attributes. Reliability means the system performs accurately and avoids what we call model drift, which is when a model's performance gets worse over time as the real world changes. Fairness means it avoids discriminatory outcomes, which is, you could argue, one of the most critical and toughest challenges we face. Explainability is the direct counter to that black box problem. It ensures that stakeholders can actually understand how decisions are being made. And finally, accountability means there are clear lines of human responsibility for whatever the AI does, always keeping a human in the loop for those really high-stakes decisions.
All right, now that we understand the framework, let's move on to Section 3 and explore the specific dangers it's designed to manage. And I want to be clear, this is not your standard IT risk assessment. AI introduces a completely new class of threats that require a whole new way of thinking.
And there is no better place to start than with one of the most famous cautionary tales in the entire world of AI ethics, Amazon's attempt to build an automated hiring tool. This case just perfectly illustrates the insidious nature of algorithmic bias.
So here's how it all went down. Back in 2014, Amazon trained a model on 10 years of its own hiring data. Now, the problem was that data just reflected a historical reality. The tech industry was overwhelmingly male-dominated. The AI, in its mission to find patterns of successful hires, basically learned that being male was a strong predictor of getting the job. The result was, well, it was staggering. The system started to systematically penalize resumes that had the word women's in them, like, say, captain of the women's chess club, and it actually downgraded graduates from 2 all-women's colleges. And this is the part that brilliantly illustrates the core lesson here. Technically, the AI was working correctly. It was doing exactly what it was told, find patterns in the data. But in doing so, it was automating and amplifying a deeply unfair historical bias.
Now, beyond bias, we have a totally new kind of security threat called adversarial attacks. This is a class of attack that is completely unique to machine learning. This isn't about hacking a server or finding a bug in the code. It's about manipulating the model's perception by making tiny, often invisible changes to its input, causing it to make a huge mistake.
These attacks generally come in 2 main flavors. On the left, you've got evasion attacks. These target a model that's already trained and out in the wild. The whole goal is to craft a special input that tricks it in real time. Then on the right, you have data poisoning, which is even more sneaky. This one targets the training process itself. An attacker will inject malicious examples into the training data to create a hidden backdoor that they can trigger later on.
Let's look at a really powerful example of an evasion attack to make this real. Imagine a self-driving car. It's approaching an intersection. To any human driver, what it sees is just a normal stop sign. Everything looks perfectly fine.
Now, an attacker comes along and places a small, specially designed sticker on that sign. To you or me, it might just look like a piece of tape, maybe some graffiti, totally harmless. We wouldn't think twice about it.
But to the car's AI, that little sticker is what's called an adversarial perturbation. That tiny, almost invisible change is enough to make the model completely misclassify the object. Instead of a stop sign, the AI now sees, with high confidence, a speed limit 100 sign. The potential consequences are obviously catastrophic. This is the new reality of AI security.
These are some profound, really scary risks. Which leads us to our final section. How did the Rulebook for AI governance evolve into the TRiSM framework we have today? Where did this come from?
Well, TRiSM didn't just appear out of thin air. Its foundations were really laid back in the mid-2010s by pioneers like IBM. They recognized that for their big AI platform Watson to succeed, people had to trust it. So they articulated this set of core principles for trustworthy AI: explainability, fairness, robustness, transparency, and privacy. This early work basically established the core vocabulary in the areas of concern. Then in the early 2020s, all these foundational concepts were consolidated and operationalized under the comprehensive umbrella of AITrust, giving us the unified framework we use today.
And that really brings us to the core takeaway of this entire explainer, which is captured perfectly in this quote. AITrust isn't just about ticking a box for a regulator. It is the fundamental operating manual that we need for this new era of technology. It's how we build AI systems that aren't just powerful, but are also responsible, safe, and ultimately worthy of our trust.
So, to wrap it all up quickly, we've seen that the old "it works" benchmark is totally obsolete because of AI's massive scale, its black box nature, and its scary potential to automate bias. To counter this, TRiSM provides a comprehensive framework built on those 3 pillars: trust, risk management, and security. We've also learned that AI introduces totally unique threats like adversarial attacks that need specialized defenses. And the most crucial point is that responsible governance is no longer optional. It's an absolute legal and ethical necessity.
We've really only just scratched the surface today. I hope you'll join us for our next explainer in this series. We're going to take a much deeper dive into understanding the AI risk landscape and break down some of these specific harms in a lot more detail.
Thank you so much for joining us today for this introduction to AI TRiSM. To continue following our deep dives, please be sure to subscribe to our channel, Tech AI and Beyond. We'll see you next time.